HTML5 canvas. So the price. One thing that we need to get out of the way when we're talking about Impact.js is the price. Impact.js is $99. It is an obstacle, but it shouldn't be too much of an obstacle because if you're good with it, you can make more money. It'll pay off in the long run. So yeah, it is expensive, but it's a fantastic engine, which I'll get into in just a moment. So the basics of Impact.js. It is a So I guess there you go. There's an option if you're into it. How are we going to do the raffle?
I'll think about it.
Spreadsheet? All right, so Impact.js is a JavaScript game engine, which means it's written entirely in JavaScript, although it runs in an HTML5 canvas. It's created by Dominic Sabluski. If you can pronounce his name properly, you're a better man than I. As I said, it runs an HTML5 canvas. It includes a tile-based level editor called Weltmeister. This is a huge feature, which we'll get to later. It runs in practically any browser, including IE. This includes mobile browsers, Firefox, Opera, Chrome, anything you can throw at it. Although it doesn't run in some older versions of iOS, because my iPod 2 will not run it. It'll run on pretty much anything. It will compile natively to iOS and possibly Android if you know what you're doing. Impact.js is an engine. So what is an engine? Impact.js is somewhat of a framework for a game. It'll handle the physics, which means how different entities, and I'll explain what entities are, interact with each other. It'll handle collision. It'll handle physical properties, such as how fast something is moving, etc. It'll handle the rendering. So it'll handle animations. It'll handle sound. It'll handle pretty much anything that'll display on the screen, including text. And it'll weave everything together. So now that you have your physics, you have your entities, you have your levels, it'll take that and build it into a coherent game. So the motor of Impact.js. This is an overview of how it works. You have your main module, which is your main, as some people might say, your main class. And this class loads levels. And these levels contain entities, which can have sounds, they can have animation, and they have physical properties. So the main module is where the basic game attributes are defined. One of the most common game attributes which will be defined here is gravity. So you define a gravity in pixels per second, which I'll talk about later. You can set global variables here, which can be accessed by all the different classes. So you can have your entities, such as if you have a player in a platformer, you can keep track of whether the player is dead or alive or his score in this main module. The main draw function is also accessed here. So if you wish to display something on top of the screen above everything else, you would display it here. So you would, for example, for some text, that's where that would go. And if you have a main menu and you want to display a picture as a main menu, that's where you would display that. There's a requires block, which initializes all available entities plus levels. So if you want to have something loaded into the game engine, you would require it in this main module. Now, Weltmeister. Weltmeister is an incredibly powerful feature. It is a tile-based level editor, which means it's built around tiles, which can be a set size. It's a configurable size per layer. It is multiple layer level creation. You are required to have a collision layer, which defines what the entities can collide with. If, for example, if you have a platformer, what the player can stand upon, what walls to run into, what the ceiling is. There's a layer for entities, which is where you place your entities, such as where the player will start. If you have signs, where the signs will be located. If you have spikes, where the spikes will be located, and etc. And you have user-defined layers, such as your foreground, your background, your middle ground, and anything else you can think of that you want. And there's a technical limit for how many layers you can have, but it's pretty large. So I'm actually going to show off Weltmeister real quickly. If you're running a local server, in this case MAMP, localhost.8, weltmeister.html. So this is a sample level. This is I'll show the game off later, but this is for week1.js, because the levels themselves are JavaScript files. And so as you can see, if I go to my main layer, I have this little paint tool. If I press space, I have access to all my tiles. The size of the tiles are defined here in the sidebar. I have a tile size of 16, which means it's 16 pixels by 16 pixels. The dimensions of the level are also listed. In this case, it's 100 pixels by 50 pixels. And the distance, you can have parallaxing, which means there's multiple layers of levels, multiple layers of layers, and they'll move independently from one another. And then you can also define if it's a collision layer, If you need to pre-render in-game, and especially in cases in mobile where you have performance problems, you can pre-render layer into the memory so it doesn't have to load it on the fly. Repeat means any tile you place will be repeated throughout the level, and you can link it with the collision layer, which means anywhere you draw will be linked with the collision. So in this case, I'm going to take a brick tile, and I can draw a brick tile like this. And then I take my collision layer, and I select a collision tile with spacebar, and I can drag and draw collision. Another important feature of Weltmeister is within these entities, you can define variables for the entities from within Weltmeister. So if you couldn't do this, what you would have to have is for every single sign, you need to define the text for the sign within the individual entity. But in this case, you can define, if I go to my entity layer, if I click on a sign, as you see, it has a text key, and the value is the text I want on the sign. And that is inserted directly into the entity's class when the entity is spawned. And that goes for anything. And now if I save this and jump into the game, reload once to make sure that it doesn't cache anything. Walk over there. There's my collidable wall. So that's Weltmeister. You'll use it a lot. There are ways to create levels outside of Weltmeister, but it's a little bit more complicated, and it has to do with creating hash maps of the different tiles. Entities. Entities are also extremely important. An entity is anything that can be interacted with. So it can be a crate, it could be a player, turret, spike, door, banana tree, falling banana, anything you want. And these are, they can be ships, and as I'll get into later, you can do a lot more than just platformers. You can do real-time strategy games, you can do dungeon crawlers. I made a little game with a helicopter, which I'll show off later. There you can obviously have independent variables per entity. All you have to do to create an entity is extend ig.entity within the entity class. And there are multiple overridable functions, such as the initialize, update, kill, and check, which is where you put your code for how the entity will actually function. And I'll get through some of these. For example, the initialize. This is where you define where sounds and images will be loaded. You can define starting positions for where the entity will actually start within the level, and you can define this within Weltmeister as well. Anything you want to happen when the entity is spawned, you'll do here. So if you want the entity to instantly kill itself upon spawning, you put a kill function within the initialize. Then you have your update function. This is what Impact.js is built in a series of ticks. Every single second, there are 20 ticks. And every single tick, this update function for every single entity is run. So movement is typically defined here. And the current animation is usually set here as well. So anything you want to happen every tick, you define here. User input is extremely easy within Impact.js. You bind keys in your main module. You can then access the bound keys from within the entity modules, and you can tell if the key is pressed and its state. So press is a Boolean that on a tick will tell you if the key was just recently pressed. And so if the key was just pressed, it'll be true, otherwise it'll be false. State means that the entity will have, if the key is being pressed, then the Boolean will be true. If the key is not being pressed, the Boolean will be false. Pretty simple. As I said, as I haven't said yet, mouse position and touch events can be done. They're a little bit more complicated than what I'm about to show you, but yes, they can be done. Actually, I'll show it right now. Within the code, to define so you go to your main class, and you can bind an input, so just id.input to bind, and then the actual key. And then in this case, for right arrow, you do right underscore arrow, and then right, so you give the key a string. And then within your player class, you can say if the input state is left, then give it an acceleration of negative acceleration, which will move it to the left. And if the input was just recently pressed left, then you set the velocity to 0, which means the entity will instantly stop. Now physics. It's based on a simple physics engine, which is based in movements in pixels per second. So that means every single second, or every single tick in this case, it'll move a certain amount of pixels depending on its current velocity and acceleration. Velocity is the speed at which the entity is currently moving, and acceleration is how much speed it picks up per tick. You can also set max velocity, which is how fast it's possible for the entity to move, because if you have a constant acceleration, it'll reach a point at which it's impossible for the entity to go any further if you set a max velocity. Otherwise, it would just continue and get really fast and fly off the map or something. There's a gravity factor, so there's a global gravity variable which defines how much an entity falls each second if in the air. And you can change that so certain entities are not as affected by gravity. And is expandable with box 2D, which I'll get into later. Collision. Collision is also really important. It's defining each entity a type, collides with, and collides mode. So each entity has one of three types. It's either type A, type B, or none. And then there's a check function which is called whenever it collides with something. Now what that something is defined with the collides with. So if it's defined collides with type A, and the entity is type A, whenever it touches type A, the check function will be called. And it will, it'll take a variable which is the entity that it collided with. For collision tiles, you can access whether the player has, or the entity has touched a tile, such as a tile on the ground or a wall or a ceiling, and you can detect where it actually touched. So you can check, if, for example, with an AI, if the AI was walking along and it touched the wall, you could detect if it touched the wall and have it flip itself. Yep. Usually it's defined like this. This is the way I've done it in the past. For a platformer, allies and yourself are always type A. And then enemies are always type B. And so, and an entity, like a bullet would be type A2. And then the entities would collide with each other. So the type A would collide with type B would collide with type A, and then all the particles would be type none, which means they don't collide with anything. And so that's the way I usually handle that. And I've seen there are walls have a type because they're handled through the check handle movement trace. So they're handled through a separate function. You could. And there are actually modules which extend, written by other people, which extend the number of types you can have. But from my experiences, it doesn't really feel like you need to have that many. Because, for example, like you said, you can have it within the check function actually check what the entity is. And if you had them all as one type, then you could check for a specific entity. Because there's entity types which are defined when you define the entity. I'm sorry, not entity types. For example, for the player, you can give the player a name, and you give it a module name. So for example, here, the ig.module is game.entities.player. And so in the check function, I can check for that game.entities.player and see if it is of that module. Animations. Animations are also really simple. They're based in tile sheets. Each entity can have one tile sheet. And the size of each tile in the tile sheet is specified when the tile sheet is defined. And so you have your tile sheet, and I'll actually show this right here. You have your anim sheet, which is your tile sheet, and you define it with new ig.animation sheet. You give the reference to where it's located, and then you have the size of each tile. Then you initialize the animation with this.add animation, and then you give a string for the name. Then you give the delay between each frame, and then you give the frames in order starting at 0. So for example, in this animation, for the run animation, I show frame 0, 1, 2, 2, 2, 3, and 4. And if you want to have a frame show for a longer time than the delay, then you obviously just have the frame displayed multiple times. And then
on the previous slide, you showed the tile sheet is kind of a grid. It's an array, right?
Yeah. And so usually I make all my tile sheets like a line. And so, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you can also have them in array where, it is an array. And then you can have multiple lines. And so once you get to 10, if you start over right here, it'll start over right here, just like you're reading from left to right and then down. This is not an actual tile sheet. I had to modify this to fit with this slide. I can pull up a tile sheet later. Actually, I have one open right. Open. Right there. So that's what a tile sheet might look like for a level. It'll look a little bit different for a player. Sound. Sound is buggy. It's easy to use though, even though it is buggy. You have to define both an MP3 and an OGG file because different browsers take different types of files. There are two channels. There's a music channel, which is where all the music is played, and it's listed in tracks. So you can define multiple tracks. So you can have music 1, and then music 2, and music 3 all on a track, which is an array. And then you have sound, which has multiple channels of sound. So music only has one channel, so you can only play one music track at a time, but you can select which track you want to play. Where sound is, you can have multiple channels, and you can play a sound here, and a sound there, and a sound there, without having to worry about them colliding with each other. Some browsers, such as mobile browsers, can only play one sound at a time, so you'll run into issues and it'll throw errors at you if you try to play more than one sound at a time. You can initialize sounds anywhere, and then play them anywhere as well, whereas music is initialized only in the main module and then can be played from anywhere. And so you can define what track is being played at any time, anywhere. And I've actually written a entity before, which can fade music in and out, so you can do all sorts of fancy stuff with the music and make it sound really nice. So throwing it all together, Josh Alcorn and I put together a game over the summer here at Gaslight called Inferno. Inferno is a game about a little knight, as you can see, who travels through the 9 layers of Dante's Inferno. We wanted to do all 9 layers, but due to time and the fact that building a game is actually really difficult, we were only able to complete 1 layer. It was made over a period of 5 days and contained a total of 5 different entities. A trigger entity, which spawned both the hurt and triggered both the hurt and the respawn entity, and then a player entity, which is obviously the main player, and then a sign entity, which displayed text. And I'll actually show that. So this is what the game looked like. As you see, we have our little paladin, and you can walk over the signs. When you walk over the signs, it displays text. When you walk off the sign, the text fades after a little bit. And there's basic jumping built in. You couldn't actually pick up the swords, which is a feature we wanted. And then there's spikes down below. Now the problem with the spikes is when you run over a spike, it actually plays a death animation. Because you teleport so quickly, you can't see the death animation. So that's one of the bugs we had. It was very buggy, but we built a full complete level, which Josh did all the artwork and animation and sound, and I did all the programming. It was made over a period of 5 days, so it just shows the power of what you can do in only 5 days, even if it was a bit buggy. Now I took this a step further when I created a game called Line Time. The goal of Line Time is I had a history project, which is due every quarter, in which we need to show creatively a series of people and dates and events in a very creative fashion. And so there's 2 aspects to the project. You have to be able to display the dates, and you have to do it creatively, like I said. So I decided I wanted to do it in an interactive video game. It's based on the engine of the game, which is Impact.js. It uses a lot of the code from Inferno, but heavily modified and expanded. It currently contains 7 levels and 3 Monty Python references. It was made in some 20 hours, and that's not including research time. And I'll show that to you guys, which I showed a little bit of it earlier. I need to check out my Git. I know. And then it's line time. So this is what line time looks like. As you can see, the signs are much expanded. They actually disappear instantly when you walk off of them. I actually did some artwork for this. I used Josh's Paladin. Now one of the big features of line time is I wanted to be able to show pictures from the internet and videos from the internet within the game. So what I did is I took a little JavaScript plugin called Shadowbox, which I don't know if any of you have used, and I implemented it into Impact.js. So whenever I click on these signs on the wall, it opens up a shadow box with the picture. And obviously that doesn't just work for pictures. It works for YouTube videos as well, which play and everything. and it contained 7 levels, as I stated before. And you can switch to any level instantaneously. That, as I said, that took me 20 hours. And it is a feature complete. A lot of bugs are fixed from line time, or from Inferno. Like when you walk over the spikes, it actually shows you dying, and then it teleports you to the respawn position. You want to see that? Get on the platform. Oops. You can do that over and over again. And actually, I'll show later on that you can drastically increase the number of gibs created very easily. But I did do more than just line time, and here's some of the features of line time: moving platforms, integrate YouTube videos and images, copious history facts. But you can extend Impact with a plugin called Box2D. This is probably the most popular plugin for Impact. It's a fully featured rigid body 2D physics engine. It's not a fluid body physics engine, which means you can't do stuff such as water very easily, but you can do rigid bodies such as any shape you could possibly imagine. It's originally a C++ library, which was ported to ActionScript or Flash, which was then ported to JavaScript, which then Dominic then modified for Impact.js. It allows for more complex manipulations of entity positions. So now you can deal with forces such as torque. You can give, vectors of motion to entities and all sorts of crazy stuff. So I took that and I built a game called Zombie Bomb. I built this in less than 5 hours. It was built with a combination of Box2D physics, and Box2D physics has its own collision system. But because that's pretty complex, I decided to go with the simple Impact.js collision models. And so if I check out to Box2D, I have a helicopter. Helicopter can fly. As the helicopter flies, it has a torque applied to it. So it's kind of difficult to keep the helicopter steady. And there's zombies on the ground. Now, obviously, how do you kill zombies if they're on the ground? Any guesses? Oh, I crashed. Bug. Usually there's a death animation played. Yeah, but are there ordinary bombs? What type of bombs would you use on zombies? You obviously drop more zombies. And you can create more zombies, place them on the ground, fly up. Oh! It blows up if you go completely upside down. So that was pretty fun. And like I said, I made this in 5 hours. I actually did this in study hall when I was at school. I think it was a good use of my time. Oh, and you can use, I actually took my original Limbo level and applied Box2D to that. And it can kind of have some hilarious results, especially when you fall off edges. Or if you hit edges like this. Can I do it? I didn't take the time to actually figure out if his feet were on the ground, and so you can't walk onto your head. And on your side, like you're swimming. So Impact.js is extremely easy to implement. All you have to do is include your main JS in Impact's Impact.js, which includes the entire engine. Add a canvas element to your HTML page, and then you're done. That's all it takes. Baking, yeah, just money just flies out of the game. Just flies out of the screen, just comes at you. There are ways to monetize it. There's a, say what? The monetization? I wish. I wish. If you look into Mobi, I believe it is, they have a monetization system which you can bake your game with their baking systems, and then it'll include ads which you can then use for profits. There's a baking script included with Impact.js, which Dominic created. You have to simply run /bake.sh, and it condenses the entire game, including the engine, into a simple minified file, which can be distributed minus the assets. You have to include the assets in their own media folder. So this way you can distribute the game without distributing the source code, which would be illegal. You can mix Impact.js and jQuery, obviously, because of the most JavaScript. An example usage, if you see my game, I used Twitter Bootstrap, and I can select a level from this Twitter Bootstrap list. To do that, all I had to do was add an HTML5 element for the level with the ID as the name of the level. Then I wrote a jQuery script to go to each level class, grab the ID, and when the ID is clicked, go using my director function, which is a level manager, to jump to that level. So that's pretty nice and useful for managing multiple levels and for a level selection screen, which you don't have to do with Impact.js. You can use any object within the document object model to interact with Impact. Going mobile. Dominic has been very nice to us and created a mobile feature for Impact.js called Ejecta. It's actually pretty recent. He just finished it a month ago, or maybe more like 3 weeks, 2 weeks. Now, you can run Impact.js in a mobile browser, as I stated before. You have to do a little bit of modification to allow for touch events. But the problem with a mobile browser is only a single sound can be played at a time, at least on iOS, which is somewhat buggy, compared to the multiple sounds you can play at once with an Ejecta. Ejecta has full hardware acceleration, whereas mobile browser has very little hardware acceleration. Game Center and IADS integration, it's standalone, whereas mobile browser requires internet access, etc. Ejecta is basically a web browser, except all it does is display a canvas element. And it's really, really, really good at displaying that canvas element. So there's an Xcode project, and you just drop your assets into a folder within the Xcode project. Then you compile the Xcode project, and you have your game ready for iOS. Now, debugging Impact.js is also really simple. There's a built-in debugging panel, which I'll show in a second. It looks like that, but there's a little bit more features. I have to check out the line time. Here it is right here. You can see the background maps, which are the layers of your level. And you can enable them or disable them. You can see the entities. You can show the collision boxes for the entities. You can show the velocities for the entities. You can show the names and the targets for the entities. For example, it's hard to see, but there is a line for the targets because there's two essentially void entities, and that platform moves between the two void entities. And so you can see it's defined through targets. And then as I saw, you can show collision boxes. There's also a performance monitor, which can show you where the game's performance is being taken up, where each draw cycle, where the most time is being spent. So you can see in this game, most of the time is being spent on the draw cycle. There's a little bit of system lag, barely anything for entities and collisions and entity updates. But as you see, if you watch on the right-hand side, you can see that there's currently 263 draw calls. If I walk over the sign, it changes to 331 because I'm drawing that box. Walk off, back to 263. And also you can see that the amount of entities changed because that box is an entity. Now, we can also do something pretty silly. And I go into Sublime, and I go to my player. And on death, rather than spawning 100 death particles, why don't we go with 500 death particles? Make sure I save that. Make sure reload once, because as I should talk about, one thing you need to make sure with Impact.js is there is a problem with caching. Chrome will store either your code or your assets locally, and then when you try to run the game and your changes aren't being updated, it's because they're being stored locally, and Chrome's drawing from that local storage rather than your own local repository. So you need to make sure that you either do a hard refresh multiple times, or use incognito mode to make sure that It's not storing anything locally. Oh, is there? Okay. Yeah, you can also use that. Make sure I do that one more time. Let's go to level 3, which has my spikes. Pull up the performance monitor, and then run over some spikes. As you can see, when I ran over the spikes, a massive amount of entity updates were being required, as well as a massive amount of draw calls. So that's what the Impact debug menu is very useful for. Oops. I think I need this anymore. Tools of the trade. There are several tools which are very useful when developing with Impact.js. One of them is Pixin. Pixin is an open source pixel-based painting program. It has very easy sprite sheet exporting. So all you have to do is create multiple layers of an animation, and it'll allow you to view the animation in real time as you're creating it. And then press a single button, it'll export it to a sprite sheet, which is accessible by Impact.js. It's open source, as I stated before, so it is free. There's a paid version in the Mac App Store, but you can get the source code for free. Use Git. No explanation needed. I'm sure you all know why you need to use Git. You do require a local Apache server. Weltmeister requires PHP, and so I use MAMP for that. I know OS X has a built-in Apache server, but I haven't dug in with how to use that. If you want to learn more, there's a book called Introducing HTML5 Game Development. It's an O'Reilly book. It's meant for the beginners, people who have never learned JavaScript. I actually learned JavaScript through this book. It contains step-by-step instructions for building a simple platformer, which is actually a game called Resident Raver, which he released on the internet, which you can play. If you're interested in playing any of my work, you can go to your web browser of choice, not in mobile yet. If you go to lay-server.com and go to either Inferno for the game Josh and I created, or Line Time for the game that I created over the fall for my history project, you can view the games I'm working on. And I'll try to keep this updated as often as possible, and I'm working on creating a homepage where you can actually view all the games at lay-server.com. Is there any questions? Are there any questions? It's pretty awesome. Yep.
When did you start programming?
Start programming?
Yeah.
I started programming, like real programming, about a year ago. And I started with Java, and as I said, I built Minecraft plugins.
Oh, yeah.
You actually made some money off of that one, right?
Minecraft plugins?
Yeah.
Yeah, I built a Hunger Games plugin. I'm not sure how many people are familiar with Hunger Games, but there's a Hunger Games Minecraft game mode where it dumps players randomly in the wilderness, and they have to fight to survive within a specified radius. And I developed a plugin to run that. I was actually, I think, the third developer of the Hunger Games plugin, so I was one of the first, or one of the third. And I made $160 over a period of a month running a server and paying people to become game makers, or people paid me to become game makers.
Yes.
That was pretty cool.
Have you played much with the packaging your games into iOS and looking at how that performs or what that development cycle looks like?
I haven't played much with it at all. I haven't played with it at all, but I've seen several examples of it, and it runs really well. I mean, it runs almost native performance, and if your game is, there's a game called, if you go to actually just go to Impact. There's a game called Biolab Disaster, which is available on the iOS App Store, and it runs, as I said, it's just based entirely in Impact.js, and it's a beautiful game, and it's actually pretty cool. I'll pull it up. Those are Biolab Disasters, and this will run in iOS, like really, really well. I haven't seen any complaints about performance at all.
So does it have any, for the iOS stuff, does it have any stuff built in for controls, like tap to move forward?
You basically create entities for your control pads, which are displayed on top of the screen, and then those, there's a, you can detect the position of the cursor, detect the position of a tap, and then you have to add it to the screen coordinates, because there's screen coordinates and then there's game coordinates.
Gotcha.
And then you can detect where the tap was, and then you can detect if it was on that entity, and then you bind that entity to a certain, to like move left or move right.
So here's a loaded question for you, Vincent.
Okay.
The game you just now showed us, you've built several games and you've tracked your time that it took you across several of those games. What do you think it would take you to finish Inferno the way that you had envisioned it compared to this bio game that you just now showed you?
Doug, don't you hate estimates?
I do hate estimating, but and that's why it's kind of a question.
I'm guessing at my current rate with school and all, probably half a year of development, and maybe if I worked on it solidly for a certain amount of time, maybe 2 or 3 months.
It's going
to build it as I envisioned it with all 9 levels.
So repeat that last part.
To build it with all 9 levels, I think it would take me a solid 3 weeks to a month of development, and if I worked on it at my current rate, probably a whole year. If I worked on it full time, 3 to 4 weeks. So I don't know how that is compared to typical game development, but that seems pretty reasonable to me.
It seems pretty fast, to be honest.
Seems pretty fast, yeah.
And that's for a simple platformer. And platformers are, I mean, Impact.js is built for platformers. You can do a lot more with it than platformers, but it added root built for platformers. And so I don't think it would be too hard. Hardest part would be AI coding. Because we had a lot of crazy AI designs, which I don't know how hard it would be to implement.
So, speaking of which, it has collision detection. Does it also have anything built in for like nearest entity detection?
Yeah, actually there is.
Yeah.
In my, let me see, pull it up. In my mover, you can get distance to target.
Nice.
Which will detect, what's the nearest target.
So that's a good way to get started with the AI, right?
Yeah.
So that's distance to target, but that's not helping you find the nearest target. You would have to iterate over and calculate to find which one would be closest, right?
Yeah, that's not too hard though.
Have a global array of where everything is and just look through that.
Yeah.
You did that in your Hunger Games plugin, right?
Yeah, what was that for?
Because you had the compass that.
Oh yeah, in my Hunger Games you had a compass. You start out with a compass, and I had a very similar piece of code to what it is right here, finding the nearest target, to iterate through all the available nearest entities and figure out the distance to the. How did I do that? I think you found the distance. You stored the nearest distance. So you start out with an infinite array, and then the first distance you grabbed, you kept that as the nearest distance, and you checked the next distance to see if it was lower than the previous distance, and if it was, you kept that as the newest low distance. And so that was pretty simple. It required a lot of calls because of the math behind it, but you could actually do distance squared, which will I think it runs pretty well. It's performance efficient. Any other questions?
I think it would be cool to see, like a lot of the classic Nintendo games, like NES.
Yeah.
You could almost recreate them using
this. I've seen actually one of the coolest things I've saw is what do they call it? It was Tetris, except you had a curved surface for the bottom of Tetris,
It's terrible.
and the blocks fell and like curved, and you had to try to create a row. It was pretty crazy.
That's some name like Madness or something along those lines.
Yeah. But yeah, I mean, I'm thinking like classic Zelda, where you're kind of moving. I guess it doesn't have the jump. And there are a bunch of games you could probably recreate.
Oh yeah.
Using this.
All right. Well, thank you very much.
Yeah, you could do that as an exercise, kind of like a painter.